Today we will be understanding what an empirical formula is and why we use it. Okay, so say you have a chemical formula of N4O2 and the empirical would be N2O1. The chemical formula tells us this is the molecule as a whole. Note this isn't an actual chemical or representation of a chemical, just a way to visualize the chemical formula, showing that all of the atoms are fully bonded. The empirical visual would be this. Now say we are only given the empirical formula, and say we are told there are 3 oxygens. With this we can calculate the number of nitrogen simply by using the formula. We know there are 2 nitrogen for every oxygen, so we get 2 times 3 and get 6 nitrogen. Now say we are given the empirical formula only of F2H5, and are told there are 35 hydrogen. If we divide the 35 hydrogen by 5, we know there is a factor of 7. Then if we multiply the factor of 7 by 2, since there are 2 fluorines for every 5 hydrogen, we get that there are 14 fluorine atoms. Now say there is a molecule made of hydrogen, oxygen, and nitrogen, and that there are 56 grams of it. Then we are told the mass percentages are 12% hydrogen, 68% oxygen, and 20% nitrogen. Since we need to find atoms and we are given grams, we need to convert grams to atom, so we are going to have to use moles to have that conversion. To find how many grams of each element there are, we multiply the total mass by their percentages. Now to get the moles, we divide the grams we just got by their molar mass. So now we want to have a ratio of elements in simplest form, which means whole numbers and is not factorable. Now the first step to finding this ratio between each element is to divide by the smallest mole to make sure that every number is greater than 1. Now we will be rounding this a bit, so now we have 1 nitrogen, about 3 oxygens, and roughly 8 1/3 hydrogens. While this isn't factorable, it has a non-whole number, and since atoms can't be fractions, we have to take care of this. So what we can do is multiply by the inverse of the fraction, so the inverse of 1/3 is 3/1. So now we get 3 nitrogen for every 9 oxygen for every 25 hydrogen. Since 25 doesn't have factors with 9 or 3, this is the simplest form with whole numbers and is not factorable. Now using this, say we are given 75 hydrogen and need to find the others. Divide 75 by 25 to get 3 and multiply this with the other elements' amounts to get 27 oxygen and 9 nitrogen.